Hello and welcome to Nikolai's genetics lessons, and today is going to be my fourth video on topic of correlation, and today we are going to talk about Pearson correlation coefficient, and today I'm going to show you calculations, how to use formula and how to do calculations. Even if you don't know formula, it is very easy. But before I will show you how to do it, I want to remind you what we have learned from the previous video. So we know that if we plot a graph, and we do need to plot a scatter plot, because we would be able to see if we have correlation or not. Sometimes correlation can be, but we still can get zero correlation when the graph is not linear, like we see here. Pearson correlation coefficient only works for linear graphs. And correlation coefficient can be anywhere between 1 and -1. From 1 to 0, we call this positive correlation, and from 0 to -1, it's going to be negative correlation. Correlation can be perfect, like here, perfect positive, perfect negative, strong positive, strong negative, weak positive, weak negative, and also can be absent. You also have to remember that Pearson correlation coefficient tell us direction and tell us strength between numbers, strength of correlation, like how numbers are spread on the graph, for example, and correlation between numbers, but doesn't tell us about slope. For example, this graph here shows us perfect correlation, and all these three graphs also show us perfect correlation, but you see slope is different. So we cannot distinguish between all these four graphs. We only can say that correlation is positive and it's perfect. And here also correlation is negative and perfect. And again, we cannot say from just knowing correlation coefficient the slope of the graph. And one more time, as I said earlier, Pearson correlation coefficient only describe linear correlations and cannot describe correlations like what you see in this graph, where if we calculate and plot all the numbers, we are going to get zero correlation, but actually we see that there is a correlation, and it's just have to be described by different formulas, and we always have to plot such scatter plots in order to see such correlations. So we cannot rely on the formula alone. And now let me explain how we can do calculations even without knowing the formula, and then I will repeat again, and next time it's going to be with a formula, and you will find how easy it would be to understand all those notations. And basically what we have here, we have two sets of data. So this is ice cream sales versus temperature. And the higher temperature goes, the higher sales of the ice cream. So this is two correlated data sets. And for example, our first step would be to find, so we have data set which we call X and Y. And our first step would be to find X bar and Y bar. And X bar stands for the mean. And how do we find a mean of each column? We just have to add these numbers and divide by the number of numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have to add all these numbers and divide by 12. This is how we get mean, and the mean is here going to be 18.7, and this is going to be degrees of Celsius. Here is ice cream sales, and if we add all these numbers and divide by 12, we are going to get 402, and this is going to be dollars. And here we have Celsius. Step number 2 is also easy. We have to put A here, B, A times B, A squared, and b squared. Now basically we have everything in order to solve this problem. In order to calculate for a, and for a, in our formula, which I will show you later, we don't need it for now, we have x minus x bar. So we take any number here minus x bar, which is mean of this set of numbers, which is 18.7. For example, 14.2 minus 18.7 would give us minus 4.5. For column B, we also would have y minus y bar. This is going to be 212 minus 402. And we have to put here minus $187. So if here we would have temperature in Celsius, here we are going to have dollars. Here is just a times b. We have to multiply these two numbers. So if we multiply minus 0.4 times minus 187, we are going to get positive number, which is 842. And in the column a squared, we just have to take this number a here and just square it or multiply by itself. And we are going to get here 20.3. And for b squared, we just have to take this number and square it. And we are going to get here 34,969. And we also have to build columns here. And we have to do the same operations for each row. So what we have done for these two numbers, these calculations. Now we have to do the same for second row, but you know now the principle how we do it. You see that even third grader can do such calculations, and here is the table which is already completed. And now let's finish our steps. Again, let me start. So we have one set of data, we call this x. We have second set of data, we call this y. We calculate mean for each data set. And then for column A, which represented in a formula by this part, we calculate the difference between actual numbers and mean. So from actual numbers, we have to subtract mean. This is how we get, for example, this number, 14.2 minus 18.7. And for this data set, we also calculate mean. And in our formula, this part of the formula stands for this calculations of this column. So we also have to do the same what we have done for the x set. So this is x, and this is going to be y set. And 18.7 is mean of x, and $402 is mean of y column. Third column is pretty easy. We just have to multiply these two numbers in order to get this number. In order to get this number, we just have to multiply these two numbers. So it's pretty easy. And then we have to square a, which is numbers here, and we have to square b, which numbers we can find in this column. And then next step, first step would be to find sum of each column. So the sum that we got here in our formula would be represented by this part. So this number go here on top in numerator, and in the denominator this part stand for this number here, which go here. One more time, a represent xi minus x bar, and b is yi minus y bar, and a times b is basically we just have to multiply these two parentheses, and a squared in our formula would be this part, and b squared in our formula is going to be this part. And in our formula, this is going to be this part. And now this number, the sum of this column and this number goes here, and we take a square root, and this is going to be our Pearson correlation number. If we would build a graph like this, which graph would represent this correlation coefficient? This one, or this one? And actually, this one would represent positive correlation coefficient, which is close to 1. Take a look. When x go up, y also go up. When x go down, and y also go down. So it is positive correlation compared with this graph where one number go up, another go down. This is negative correlation. And the third graph shows no correlation at all. And if we'll build a scatter plot, which scatter plot would represent this number, and this number is going to be somewhere in the middle, so it's going to be strong positive correlation. Those not perfect, where if we know one number on one axis, we can tell for sure the second number on the second axis, and our line is going to be perfectly straight. We only cannot tell the slope of this line, but we can tell numbers if we know one set of numbers, and if we have perfect straight line, we also can predict second set of numbers. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day, and see you in the next video. Goodbye.